for this fourth example, I'm just gonna work on it all the way through. So before we start, I just want you guys to fix something here. Um, I want you guys to change the initial condition. On yours, it says that y of 0 equals 0. I'm gonna change it to um, y of 2 equal to 0. Um, and then also in addition, oftentimes the initial condition would be written using the f function. So it'll say f of 2 equals 0, and that just means the same thing. Um, I just chose the y so that we could pay attention to the when we said the y function at the end. So just keep in mind, you'll see f of 2 equals 0, and I think this is actually the most common one, but I like to use it so we know that we're talking about a function of y. Okay, so the first step, like the other ones, is to separate the variables. Okay, so I'm going to copy the problem down. So we have dy over dx equals y minus 1 over x squared. And I'm going to multiply both sides by dx. And then we'll have these cancel each other out. And so we'll have dy equal to y minus 1 over x squared dx. Okay, so I'm going to have to rewrite the right side here so that it could be a little more apparent about how I'm going to get this y minus 1 to the other side. I'm going to want to divide it, so I'm just going to do it like this. I'm going to rewrite the right side as 1 over x squared multiplied by y minus 1 dx. Now I can see that I'm going to want to divide both sides by y minus 1. So I have y minus 1, divide this side by y minus 1, and I'm going to throw a 1 here in the numerator. So what we have is 1 over y minus 1 dy equal to, these canceled, so we have 1 over x squared dx. Okay, so we successfully separated. Now we can move on to the second step of the method, which is to integrate. So what we'll have here is we're going to integrate 1 over y minus 1 dy and 1 over x squared dx. So I'm going to solve each side here, the subproblem, and I'm just going to do it on each side. I'm going to do the work on the side just to keep things organized and not have everything crowded here. So I'm going to integrate the first one first, and just looking at it, and I'm going to use substitution. There's going to be an ln step in there somewhere. So, and if you guys can figure out a shortcut that I can use, that I can bypass using u sub to figure out the integral of 1 over something, then you guys can share it with us, because it's definitely something. So I'm going to let u to be y minus 1. Therefore, du is going to be 1 dy, and that means dy equals du. Now I'm going to integrate 1 over u du. We know the integral 1 over u is ln, the absolute value of u, plus c. And now I'm going to plug in my u, which was y minus 1 plus c. So that's the left side. So I'm going to add it here. So we have the ln of y minus 1 plus c1. Okay, so now the right side, we have the integral of 1 over x squared dx. Okay, so this one, we're not going to use u sub because I can make this look like a polynomial. So I can rewrite this as x to the negative 2 dx, and now I can use the add 1 divided by new exponent rule. So we'll get x to the, let's see, if I add 1, I'm going to get x to the negative 1 divided by negative 1, so there'll be a negative 1 here, plus c, and that can be rewritten as negative 1 over x plus c. Okay, so I'm going to bring that result to this side. So that we'll have negative 1 over x plus c2. And just like the previous one, these two are just going to become one constant. So we're just going to chunk them together. This is going to be just one big c. So we'll have so far ln of y minus 1 equal to negative 1 over x plus c. So this one here, again, we have an ln. Now I need to decide if I want to solve for y first or I want to solve for c first. So just like the previous one, I'm going to go ahead and solve for y. And then we're going to solve for c and then write the particular solution. So I'm going to solve for y first. Okay, so just like the previous one, we're going to have to get rid of this ln by exponentiating both sides. So I'm going to make all these become the exponent of e. So these are the exponent of e. So the e and the ln will cancel each other out. And so what I have left is ln, the ln canceled out. So I have y minus 1 equal to e to the power of 1 over x plus c. So using the rule, the rules of exponent that I was talking about, I'll explain it once again here, but I'll kind of summarize the quickest way to deal with it. So e to negative 1 over x plus c can be rewritten as e to the negative 1 over x times e to the c. This itself is a constant, so I'm going to replace it with c, and so we have c e to the negative 1 over x. So the quickest way of kind of like not of skipping this step is once we get to this part, what we'll want to do is just y minus 1 equal, and I'm going to automatically put a c, and it'll be e to the negative 1 over x. That way I don't have to like go through the step over and over, but it's good to know this just in case you forget that shortcut. Alright, so now we have this equation. We want to solve for y, so I'm going to solve for y by adding 1 on both sides. And so we'll have y equals c e to the negative 1x plus 1. So this is our general solution. Okay, now we can solve for c. Oops, this should have been a 3. Okay, so we're going to solve for c, and then we'll present our solution. And our initial condition was 2, 0. Okay, so we'll have 0 equal to c. Let's see. Okay, so e to the negative 1/2, because our x is 2, and then we have the plus 1. Okay, so this works out to be the case that if I subtract 1 on both sides, I'll have negative 1. So I have negative 1 equal to c e to the negative 1/2. And now I want to solve for c, so I'm going to have to divide both sides by e to the negative 1/2. And that implies that c equals to negative 1 over e to the negative 1/2. And I want the exponent to be positive, so I'm going to bring it to the numerator, and it'll just become negative e to the positive 1/2. So that's my final c value. Okay, so that's my C, and now I want to plug that in for where I see C in the original problem. I'm sorry, in the general solution. So this guy is going to go here. So my particular solution is going to be y equals negative e to the 1/2 e to the negative 1 over x plus 1. Okay, so it's kind of awkward so at this point we have the solution, but I want to kind of clean this part up. So this will just be, I'm gonna, since these two terms are factors are have the same base, that means I can add the exponent. So we'll have negative e to the 1/2 minus 1 over x and then plus 1. So this will be the final solution. This is the particular solution. Okay, so just to summarize, the 4 steps still apply, right? The separating part, and then the integration part. And the integration part, the part that takes a good amount of time is the integration step. So that's why it's important for you guys to be able to integrate quickly, but you do have to take your time to do it. And then step 3, that itself, that step also requires a little bit of it has a little algebraic complexity, but hopefully you guys could use that idea of just having C in the front here when you have the E both sides. And the last step here, this is not going to be the case for all problems, I think, but everything stays the same. It's just the process of solving for C was a little more involved. So for solving differential equations, you guys need to just take your time doing it. Make sure you do each step carefully, so that you don't have to pick up your mistake later on. So it's important for you guys I suggest that you guys talk to each other and maybe get together and compare your work at each step, so that you guys don't realize that you have a mistake at the end, but that's just part of the process. So hopefully those 4 examples were clear enough for you. And if you have questions, you guys could make sure you email me or send me a text through Remind. So I suggest at this point, review the 4 examples again, and then give a try the practice problems. I'll post the solutions for those. I'm thinking about video form or written form, but you'll see them. And then if you guys have further questions, then like I said, just reach out to me or one of your classmates.